Hello, grade 11, here Mr. G, and we're going to continue with the videos related intermolecular forces. In this case, we're going to be talking about the van der Waals forces. So let's start by listing out the different van der Waals forces we have. Okay, the first van der Waals forces we're going to be talking about is the dipole. And something important, the dipole forces have a special case which is called hydrogen bond. Now, hydrogen bond is not a bond. It's not a bond between atoms. Still an intermolecular force, but is a intermolecular force we're going to be speaking about. Is a special case of dipole force. Okay. The second one is going to be the second type of intermolecular force is going to be called dipole-induced dipole, and the last one is going to be called induced dipole forces. Induced dipole forces, and the induced dipole forces sometimes is going to be called London forces and other time is going to be called dispersion forces. Okay, I personally prefer to call it London forces. However, that is just a term. At the end is the same force, just we using different names. So the van der Waals forces, we have dipole forces. We have a special case of this one, which is called hydrogen bond. We have dipole-induced dipole forces, and we have London forces or induced dipole forces. Those are the three forces that belong to van der Waals forces. We are going now to go to each of them especially and leave the hydrogen bond for last one. Okay, so let's start with the dipole forces. So let's begin with the dipole forces. Now, dipole forces are attractive electrostatic forces between permanent dipole molecules. So this type of forces will appear when two dipole or polar molecules come into contact with each other. Alright, that is the first important thing. The dipole forces will appear when there are two dipole force the molecules in contact with each other. Let's see one example. Let's see hydrogen chloride. We have hydrogen chloride. I'm going to do the Lewis dot diagram for hydrogen chloride. I'm not going to explain how it is done because that was done previously in one video. Okay, now what we need to know, in this case hydrogen have less electronegativity, so on this side, this molecule on this side will be slightly positive, and chlorine have a high electronegativity, will pull the bonding pair a little bit stronger, it will be slightly negative. Okay, so now what we have different molecules interacting of hydrogen chloride. Let's say, for instance, we have three molecules of hydrogen chloride. Remember, there is no such a thing as only three molecules. There's millions of molecules in one drop of hydrogen chloride. Okay. Now, there are three molecules. What happened with these three molecules? The positive side of one molecule will be attracted by the negative side of the other. In this case, the first molecule, negative side, will be attracted by the positive of this second molecule, and the same will happen with the other two molecules. This here is what we call the dipole forces. That there is the dipole forces. That is the intermolecular forces. Or this one is the same. It's between the positive side of that molecule with the negative side of the other molecule. That is why it's called electrostatic attraction between those two different molecules. So this is how the dipole forces appear, and I hope it's clear. Let's go to the second one, which is not going to be hydrogen bond. We're going to keep hydrogen bond for last. So let's go to the next type of van der Waals forces. Now, the second one is dipole-induced dipole forces. Now, what is going to happen? This exists between any polar molecule and a non-polar molecule. Now, non-polar molecule could be symmetrical atoms or molecules. Alright, those could be also non-polar molecules. So it doesn't need to be a molecule. For example, the noble gases, they exist as atoms. They don't form molecules because they don't bond with each other. Okay, so that could be the example. Let's see one example. Let's see, for example, argon, one of the noble gases. So argon is a symmetrical atom. it does not have, it's not polar because it's a symmetrical atom, so it doesn't have two poles. Now let's make argon to be in contact with hydrogen fluoride, for instance, which was the first example, and is a polar molecule. Let's see what will happen. Now, when argon is in contact with hydrogen chloride, for example, this negative side here will repel the electron of argon, and the electron of argon will be shifted towards that direction because they've been repelled by the negative side of that molecule. And the other way around, the positive side of the hydrogen chloride here will attract the electrons to argon, and then argon will become temporarily a polar atom. So this argon will temporarily be negative on this side and positive on this side, and that is how they attract each other. And there will be forces between the negative side of this molecule and the temporarily positive side of argon, and the other way around. This negative side of argon will be attracted by this positive side of hydrogen chloride. So what did happen here is the hydrogen chloride induced a polar atom on argon. This here is what we call dipole induced dipole forces. Is the forces between a polar molecule, in this case hydrogen chloride, and a non-polar molecule atom, in this case was argon. So that there is the dipole induced dipole. So this hydrogen chloride is producing a polar molecule to argon. Okay, and those forces that keep those two substances together is what we call dipole induced dipole. Let's go to the last case. Now, this one is the London forces. London forces exist between two non-polar molecules. Here will be between two non-polar molecules. For example, let's see the case of iodine molecules. If we do the Lewis dot diagram for iodine, remember I am not going to explain how it is done. You can watch the video. Here is iodine. That will be the Lewis dot diagram. This one is a linear molecule and is a non-polar molecule. Okay, so this molecule doesn't have two poles. Let's see what happens when they come into contact with two or more different iodine molecules. So here is iodine. Now, iodine is a non-polar. What will happen? Okay, sometimes because the electrons are moving too fast in one of the molecules, may happen that all the electrons are going to be towards one side, or most of the electrons are going to be towards one side of the molecule, and then those electrons move to one side. Therefore, that side of that molecule will be more negative. Now, this molecule, when it comes in contact with the other molecule, also it happens similar. Those electrons are going to repel each other. So for instance, here is more electrons, this one becomes slightly negative, and this one becomes slightly positive, this side of the molecule. So all the electrons of this specific molecule now will be attracted by those. So all the electrons will shift towards that side there, making this molecule to be slightly negative on this side and slightly positive on the other. And the other way, the electrons will be repelled, so all the electrons will attempt to shift towards that side. That's just right here. Electrons move towards that side, and then this becomes slightly positive, and this becomes slightly negative. So this happens how this non-polar molecule is producing a polar molecule on the other one. Now this is what we call London forces. The force between this negative side of this molecule here and the positive side of the other. These attractions here is what we call London forces. London forces or induced dipole forces. It's the forces between two non-polar molecules where they are going to induce a polar molecule among themselves. They're going to push electrons away or towards, and they're going to produce a temporarily polar molecule within themselves. Okay, so this is what we call London forces. I hope it's clear. It's not that difficult. The first or the most important thing is you need to understand that the London forces will happen between two non-polar molecules. So if you want to identify the type of intermolecular forces, the first thing you have to find out is what type of molecule is it, if it's polar or it's non-polar. And then we only have left the hydrogen bond. We're going to be looking at a hydrogen bond right now, real quick here. Okay, so hydrogen bond formed between a hydrogen atom. Obvious, hydrogen bond must have hydrogen atoms involved. Now, that hydrogen atom must be bonded straight to either one of these different atoms. So, hydrogen atom must be straight bonded to either nitrogen, oxygen, and fluorine. So, it's not any molecule that has hydrogen, or is not even any molecule that have hydrogen and oxygen. Is a molecule that have hydrogen bonded straight to one of these molecules. Let's see one example so you understand what I'm saying here. For example, this molecule here, I dot the Lewis dot diagram, is called methanol. You will learn about this type of molecule later on when you are in grade 12. And if you are in grade 12 already, then you know what I'm talking about. So here you have oxygen, you have hydrogen. However, the oxygen and the hydrogen are not bonded. The oxygen is bonded to carbon and the hydrogen is bonded to carbon. Remember, hydrogen must be straight bonded to either one of them. So this molecule cannot form hydrogen bond. It does not form hydrogen bond. So this molecule of methanol cannot form hydrogen bond. Okay, it cannot form hydrogen bond. Why? Because it does have hydrogen, it does have oxygen, which is one of the different atoms, but they are not bonded straight. Now let's see the example that it can actually form hydrogen bond. Now in this other molecule here, you can see you have hydrogen bonded straight to oxygen here. So this molecule can form hydrogen bond. This molecule is called methanol. This is methanol. Note, this is methanol, this is methanol. They are different compounded, different molecules. Later on, you learn about that. And this one has hydrogen straight bonded to oxygen. So here, this molecule can form hydrogen bond. It can form hydrogen bond. I hope it's clear the difference between the two molecules to identify when a molecule can form hydrogen bond and it cannot form hydrogen bond. Note this specific molecule here at the bottom, this one here, the methanol, it is a polar molecule. So it's polar. Two of those molecules will form dipole-dipole. This one is also polar. But the second one, methanol, can form hydrogen bond, and the methanol cannot form hydrogen bond. So let's see quickly one example to see the hydrogen bond, how it is formed, and then we'll finish the video right there. Now here you can see three molecules of water. Now where is the hydrogen bond? The hydrogen on one molecule will bond with the oxygen of the other molecule. The hydrogen of one molecule will bond with the oxygen with the other molecule. This is what we call hydrogen bond. And I think this is everything related to the different type of intermolecular forces. Last video we looked at ion dipole. We look now the van der Waals forces. Okay, so now what is just left for this video, and I want to just mention that one here in the list when we listed. Which one is the strongest one? So I'm going to organize them, and listen carefully because I'm going to write just numbers here. Okay, I'm not going to write the list. From stronger to a weaker. So which one is the strongest of all these molecules? Number one will be the hydrogen bond. That is the strongest one of all. Followed by dipole-dipole. This is number 2. Then is dipole induced. This is number 3. And the final one is the London forces, that is number 4. So the strongest one is hydrogen bond. The second stronger is a dipole-dipole. Remember, hydrogen bond is a special case of dipole-dipole. So in actual fact, hydrogen bond is a dipole-dipole forces. Then is dipole induced, and the weakest one of all is the London forces or induced dipole forces. So here is the last part of the video. I hope it helped. Remember, please, if you help, you can thumb up if the video helped you. If you like it. This video is special for grade 11 and grade 12. Thank you for watching and good luck.